Okay, so hello everyone, welcome. For today, we are going to talk about chemistry, all about electron configuration. So, first one is over here. We have here an element, the element neon, with an atomic number of 10 and a mass number of 20. Now, we're just going to focus all about on the atomic number. Okay, so the neutral atom of neon has an equal number of protons and electrons. If hindi naman siya equal, yung protons and electrons niya, it is already considered as an ion. Okay? So how do we note or how do we write the electron configuration of neon? So to do that, we need this standard electron configuration. It includes the energy level and the sublevels. Okay, so these numbers are what you call the energy levels, and these S, P, D, and F, those are the sublevels. And each sublevel can hold up and a specific number of electrons. For example, here we have the S sublevel, which can hold up to 2 electrons. And the P sublevel can hold 6 electrons. The D can hold up to 10 electrons. And the F sublevel can hold up to 14 electrons. Okay, so we are going to first start with the lowest sublevel, which is 1s squared. So that is what we put here, followed by 2s squared and 2p6 and 3s2. Now, the reason why we stopped at 2p6 is because we already reached the number of electrons needed, which is 10. So in order for you to know that, you just have to add all of those exponents up, and that will result to 10. So that is the electron configuration of neon. Now, an element can either be paramagnetic or diamagnetic according to how they are attracted to magnetic fields. So if elements are paramagnetic, it means that they have unpaired electrons, okay? They are attracted to an external magnetic field. But if an element doesn't have any unpaired electrons or it is complete, it is weakly repelled by a magnetic field, resulting that element being the diamagnetic. Okay, so neon here, the element neon is one of the examples of a diamagnetic element. Because as you can see here in this orbital diagram, uh, none of its electrons are unpaired. So every electron here has a pair. Okay, so let's move on to phosphorus, which has the atomic number of 15 and the mass number of 31. Now, the electron configuration of phosphorus is this. So it's quite long. So there is a way that we can shorten this electron configuration, especially when you're dealing with elements that have a higher uh, atomic number. Okay, so to do that, we need to use the noble gas notation. Okay, so how do we do that? The first step is for you to find a noble gas that has a close and lower atomic number than 15. Okay, so once you find that noble gas, you just put it inside a parenthesis and you just write down what is left and in the electron configuration. So for this for phosphorus, the closest noble gas is neon. Okay, and the electron configuration of neon is 1s squared, 2s squared, and 2p6. So what's left is 3s squared and 3p3. That's why this is the final electron configuration of phosphorus using the noble gas notation. Okay, now let's talk more about the orbital diagram. Sorry. So as you can see here, phosphorus has 3 unpaired electrons over here and 12 paired electrons. Okay, so an easier way to know how many paired electrons an element has is for you to subtract the atomic number and the number of unpaired electrons, and you will get the number of paired electrons. As I said earlier, if you're dealing with elements that have a higher atomic number, this might be helpful for you. Okay, so that's 15 minus 3 is equals to 12. Okay, so now here we have the full, sorry, may nag-admit. Okay, this is the full orbital diagram of phosphorus. So as you can see, there is a pattern that you have to follow when placing your electrons. Okay, so it's not up and down. Okay, so we're going to talk more about that over here in the orbital energy level. Okay, so we're still in phosphorus. Yung base natin na element is still phosphorus. Okay, so now we have three ways in order for us to illustrate the electron configuration of an element. So the first one is just listing down everything, or listing down its sublevels. Okay, the next one is the orbital diagram, and the third one is this, the orbital energy levels. Now, when it comes to illustrating electron configuration, we need to follow certain principles and laws or rules. Okay, so the first thing that you need to follow is the Aufbau principle. So according to this principle, you need to add electrons to these orbitals in order of increase in energy levels. By the way, every orbital can hold up to 2 electrons. Okay, that is why in our S sublevel we only have 1 orbital, and in our P sublevel we have 3, because the P sublevel can hold up to 6 electrons. Okay, so these black lines represent our orbitals, and these green arrows still represents our electrons. Okay, so the Aufbau principle applies in these orbitals, okay, these sublevels. Kasi according to this, you need to add those electrons in order of increase in energy levels. Now, to put that in simple words, kailangan mo munang ma-occupy lahat ng space sa pinakamababang sublevel before you move on to the next one. Okay, that is why we have our 1s and 2s filled. Okay, so bakit siya alternate? Bakit siya up and down arrows? Bakit hindi na lang lahat up arrows? It's because, as we all know, electrons have negative charges, and when we put two particles of the same charge together, they will repel. So when that happens, it creates instability inside the atom. Okay, so we don't want that. That is why we need to place the opposite particles of the different charge in order for the atoms to be stabilized. Okay, so here we have the 2p sublevel. Now the Aufbau principle doesn't apply to this because there are 3 orbitals with the same energy level. So ano yung uunahin mo dyan? So how can we explain that? That is where the Hund's rule comes in. Now, these orbitals that have the same sublevel and the same energy are known as degenerate orbitals over here. So according to the Hund's rule, whenever you're dealing with degenerate orbitals, you need to add them, or you need to add those electrons one at a time with parallel spins. So what are parallel spins? Now, imagine na wala pa tayong mga down arrows dito. Okay? Wala pa yung mga yan. So the correct way of placing your electrons is using parallel spins, meaning you need to place one electron per orbital first before you fill it up twice. So kailangan muna lahat ng orbitals ay magkakaroon ng electrons bago muna lagyan ng opposite spin. or down arrow. Okay? So ganun yung correct way of placing your electrons when you're dealing with orbital diagrams or orbital energy level. Now, paano naman nagka-down arrow dyan? So, this is where the off-bow principle comes into effect once again. Ngayon na meron na tayong electrons for every orbital in the 2p sublevel, pwede na natin siyang punuin since meron pa tayong mga electrons na hindi na-place. So that is why we have these opposite spins or the down arrows in the 2p6 sublevel. And the same principle applies in 3s squared. And here naman sa 3p, in the 3p sublevel, as you can see, wala siyang down arrows because we only need 3 electrons in this sublevel. So, ayan yung correct way of writing down or illustrating your electrons using orbital energy levels. Okay, and the more unpaired electron an element has, the stronger the interaction between that element and the magnetic field. So, yan tinutukoy na unpaired electrons is these. Okay, so wala siyang kapartner. So, parang nag-iisa lang siya sa orbital niya. Those are unpaired electrons. Okay, so let's talk more about the magnetic fields. Okay, so a moving charge will create its own magnetic field, meaning that charge must be in motion, not stationary. Okay, and as you can see here from the picture, this circle here is the nucleus. It represents the nucleus of the atom, and these blue arrows, they represent the electrons revolving around the nucleus. And this yellow arrow, as you can see, this represents the direction of the magnetic field. Now, the direction of the magnetic field is based on the direction the spin is. Okay, so pag yung electrons are moving towards the right, the north or the direction of the magnetic field is upward. Pag the electrons move to the left naman, or they revolve to the left, the direction of the magnetic field is downwards. So, yung pag to the right siya, yung north niya is nasa taas. Pag opposite naman, yung north niya is nasa baba. And the electron spin here, when it comes to the revolving to the right, it is positive 1/2. And the other way around, it is going to be negative 1/2. So this is more on the physics side. So this is a brief explanation or brief introduction in the magnetic fields in the atom. Okay, so here, I have here an example wherein you can apply those things that we just talked about. Okay, so which atom or ion contains the greatest number of unpaired electrons? Okay, so we have 5 choices here. The first one is phosphide ion. The next one is iron. The next one is ferrous ion and ferric ion, I believe, and chromium. Okay, so in order for us to solve this, we need to we need to know the electron configuration for every element here. Okay, so this is the electron configuration for letter A. So the electron configuration of phosphorus is this, which has the atomic number of 15. But in this case, this is phosphide ion. So this is already an ion kasi nadagdagan siya or nabawasan siya ng protons. So, nadagdagan yung electrons niya. So, this phosphide ion is called an anion. Okay? So, anions are negatively charged ions. Cations are positively charged ions. Okay? So, all we need to do here is to add 3 electrons since nabawasan siya ng protons. Okay? Kaya naging 3p6 instead of 3p3 yung electron configuration ng phosphide ion. Okay? Resulting to 18 electrons or 18 atomic number. Okay? So, pag pinlock natin yung 3p6 sa orbital diagram, ganito yung magiging itsura niya. So, as you can see, wala siyang unpaired electrons. Lahat, yung 3p6, complete siya. Okay? So, here is the electron configuration for letter B naman. The atomic number of iron is 26. And this is the atomic number. And when you use the noble gas notation, this is the result. Okay, argon 4 is squared 3d6. Now, if you're going to use the orbital energy level, but you can also use the orbital diagram. I'm just showing you how to use the different kinds of illustration using applying it into a problem. Okay, so this is the 4s sublevel and the 3D sublevel. So as you can see, we have 4 unpaired electrons right here. Okay, so ganyan siya. Parallel spins muna, up arrows muna, and nilagyan niya na ng down arrow kasi nga meron pang isang remaining electron. Okay? So, dito naman sa letter C, we have ferrous iron. So, yung electron configuration ng iron is argon 4s squared and 3d6. Pag dating naman sa ferrous iron, we have argon 3d6. So, paano na-cancel yung 4s squared? Okay? So, ang nangyari dito is kailangan natin mag-cancel ng dalawang electrons kasi nadagdagan siya ng protons. So, according to this, kailangan natin magbawas ng electrons sa pinakamataas na energy level, which is 4s squared. Okay, mas mataas yung energy level ng 4s squared kasi sa 3d6. Kasi ang energy level dito is yung numbers, di ba? Okay? Kahit mas mataas yung sublevel ng 3d6, mas mataas pa din yung energy level ng 4s. Okay, so dyan tayo nag-cancel out ng protons or ng electrons, Okay, so ayan yung orbital diagram ng 3d6. So as you can see, we have 4 unpaired electrons for ferrous iron. Now let's go to letter D, which is ferric iron. So dito naman, nagbawas pa tayo ng isang electron sa 3d5. Okay, kaya hindi siya naging 3d5 kasi nagbawas tayo ng 3. So as you can see, this is the electron configuration of 3d5 or the orbital diagram. So as you can see, we have 5 unpaired electrons. Now let's go to letter E, which is the last one, and this is chromium. Now, the expected electron configuration of chromium is this, argon 4s squared 3d4. Okay, so bakit hindi yan yon? Okay, because the correct answer is argon 4s1 3d5. Now, chromium is one of the exceptions, okay, to some of the elements. Okay? Dito kasi, the 4s squared and 3d sublevel is not that far away from one another when it comes to orbital energy levels. Okay? Magkalapit lang sila. So, what happens here between the electrons of chromium, there is electron repulsion. Okay? During this, one of the electrons or some of the electrons are being repelled by the others. Okay? And in chromium's case, this electron right here is being repelled by this one. Okay? And that creates instability in the atom. Okay? So in order for this atom to be stabilized, this electron must find its own space. Okay? And it sees this empty space in the 3D sublevel and it jumps into that, which requires, of course, energy. So during that process, the instability of the atom minimizes. Okay? Kaya, naging 4s1, 3d5 yung electron configuration ng chromium. Okay? So, ang magiging final orbital energy level niyan is ganito. Okay? So, excuse my drawing. So, ayan. Wala na yan dyan. Lumipat siya dito. kaya siya naging 4s135. Okay, and the final answer for that is it has 6 unpaired electrons. So we have our answer, and that is letter E, chromium. Okay, so that's it. Okay, so ayun lang. So yeah, I'll be uploading this uh, live session in our YouTube channel if you want to go back to it, and I will be handing out our quiz for today in our group chat in our Google Classroom. Okay, and sad to say, this is our last live session for I don't know for how long, because next week magsa-start na yung online classes ko. So to all of you, thank you so much for don't be sad. Thank you so much for attending our last live session, and I really appreciate everyone that attended our live session from the start till the end. Okay, so I'm really gonna miss you guys, and um, teaching you every week and interacting with you guys weekly. So yeah, I'm gonna miss you too. So ayun lang guys, thank you so much, and I hope you the best of luck in your uh, upcoming entrance exams and our grade 12 life if incoming grade 12 kayo or incoming senior high uh, students. Okay? Thank you so much po. So ayun lang guys. Goodbye. Joke lang. See you next time. Yun lang.